Janani ma'am, shall we start, ma'am?
Yes, sir, we can start now. Shall we, sir?
Yes, ma'am. Just one more minute, ma'am.
Yes, sir.
Good afternoon, all of you. On behalf of Department of Computer Science and Engineering, Chalapati Institute of Engineering and Technology, I welcome all of you for this guest lecture on DBMS. So, in this regards, I like to thank Janani ma'am, Assistant Professor, KPR College of Arts and Science and Research, for accepting our request and coming as a resource person for this guest lecture. Thank you so much, madam. In busy schedule also, you have given acceptance and you came forward to be as a resource person for this guest lecture. Over to you, ma'am.
Thank you, sir. Thank you so much. So I think I can share my screen.
Hello, ma'am.
Yes, sir. Give me a minute, sir.
Yes,
sir.
ma'am. Okay. I think you are logged in multiple devices, madam.
Yes, sir. That is for video
Yes, sir, that is for
purpose.
video purpose.
Okay, okay.
Is my screen visible, sir?
No, you have not shared anything, no, madam.
Share now, sir. I don't know.
Okay.
Some technical issue. Give me a minute, sir.
Okay. Yes, ma'am. Now your screen is visible, ma'am. I think you are muted, ma'am. You can click on that share, ma'am.
Sorry for that. My system is slow. Give me a
Okay.
minute. Sorry. I hope now it is okay.
Ma'am, actually PPT is not visible, ma'am.
Yeah, yes, now it will be. I'll change the screen.
Yes, ma'am. Now it is visible.
Yeah, yes, sir, yes, sir.
Yeah, ma'am.
So good afternoon, everyone. I'm so happy that in this afternoon, after having your heavy lunch, and you have connected here to
This meeting is being recorded.
connected here to gather some information regarding DBMS. And I know that since many of the students are connected, obviously my session is going to be useful if you want to learn the basics of DBMS. So let us jump into the session. So these are the contents what we are going to discuss now. So first one is introduction, followed by what is relational database and a few things regarding it. And similarly, we'll be knowing, we are not going to study in depth on SQL commands, but anyway, I'll ask some questions to you and you're going to post it in a chat box. You're going to post the answers in the chat box. Let us see. And followed by normalization techniques and database management tools, means currently what are the tools available and so on. And finally, we'll be having Q&A session. So, okay, database management system. So we will start by knowing what is data. So in a simple way, we can say that everywhere data exists. Means you are chatting with your friends, right? You're sending some images to your friend, or audio to your friend, or video to your friend, and you're receiving it back sometimes, right? So these are actually data. This is what actually what we are generating without knowing that it is a data. Yes. And similarly, in social media, we can see that TBs of data is generating per second, and especially on YouTube and so on. So how it can be manipulated? So it is again different, and it's a current technology which we have to speak. But here I'm not going to touch those things, and just let us know what is data. It is a collection of information. Unless you're going to fetch some record, it is going to be useless. So database, this collection of data should be organized in such a way where you'll be using it for your further or in your future. Yes. So okay, what can be a database? For instance, I hope many of you are students here, so I can take that as an example. Usually I start with this example. Say in your class, okay, in your class, just imagine you have 50 students. Fine. So you will be storing those data in a form of table or in Excel sheet, whatever you want. You'll be doing, right? With the with starting from your register number, name, and whatever detail you are in need, like which class, which department, and who is your class advisor or something like that. What are the important detail you require? You'll be storing in it, even phone number, Aadhaar card number, whatever you want. So this type of database, we can say it as a structured database. Means you can retrieve the information whenever you want easily, right? By using the we can say that by using your student ID, we can easily fetch the record. Okay, okay. The next question is, okay, I came to know what is data, what is database, but how I'm going to manipulate these things? Just imagine what I have said is for only 50 students, but imagine for a whole university. Just imagine that the university contains affiliated colleges around 50 or 60. Okay, so you'll be having thousands and thousands of record over there. So how would you fetch record? Will you do some calculations, or will you search for each and every record? It is not possible, right? So that is why we need database management system to manipulate this database. So why we need DBMS? It is much convenient and efficient to use rather than our traditional methods. Usually we are, in our early, we might have not faced that much issues, but our elder, maybe they might have stored everything in their file, and they used to search each and every time whenever they require. So this is what happened usually. So database systems are used to manage collections of data that are really valuable and large one, and which data you're going to means it is going to be accessed by multiple users concurrently. Fine. Means if many people are there, and if they try to access the database simultaneously, then obviously the consistency of database will be questioned. So for that, we are having DBMS to tackle these type of issues. Okay, and similarly, we have some modern database system also, which is used to access, as I said, images, audios, videos. Now, it is currently technology is, improving on that side, and definitely there will be a huge difference when we reach I can say myself, when I reach 50s or 60s, definitely good database system, a complex software system that will be going to reach to manipulate these audios and videos even much faster. Okay. Give me a minute. Okay, let me ask some questions so I can understand who are all connected here. Okay. So I hope everyone knows keys, right? Those are connected. Can you say what do you mean by keys? So I can understand that I'm not speaking alone. I expect good interaction. Oh, very good. Thank you, Ravi. Okay, fine. I received one, chat from Ravi. Okay, attributes. Yeah, very good, Rajesh. Okay, please explain. Shubra. Okay, thank you. I now I could understand that few of you are listening. So features. So I think that one is Kiran. Thank you. Yeah, good. See, keys are nothing but let me start with primary key first. Here, what you can see. What is this first? Before explaining key, let me explain relational database. See, this is what a structured database is. Fine. See, it contains columns, it contains rows. Yes, if I want to fetch some record, I want to access the second one, like Amazon, and its status is active, how I can fetch this? Any idea? Okay, I'll explain. Okay, relational database is nothing but where your database is in a structured way. You'll be having two important components, that is rows and columns. So columns here, what are the attributes? Someone has said as attributes, someone said as features. Yeah, everything is same. Here I can say customer ID, customer name, status. These are termed as attributes. I hope now you can get what does attributes, right? And here, if you look at my monitor, you can clearly see that first row, second row, and third row. These three rows means in this particular relation. Here, I'm not mentioning it as table. I'm mentioning it as relation. In this relation, I'm having three tuples. That is what I have mentioned. Tuple are row, and column are attributes. You can say this one as column or attribute, and you can say this one as tuple or row. Any doubts so far? Yes, any doubts so far? I hope no. Yeah, okay, thank you. See, ACID properties. So this is if you are going to face an interview, you can expect this question if they ask something on SQL. So ACID refers four components: atomicity, consistency, isolation, and durability. Fine. So what do you mean by atomicity? Okay, let me go with an example. Just think we have two table or relation termed as A and B, and at the same time B wants to transact with A. Fine. So what happens? Just imagine that A wants to send rupees 100 to B, and B wants to send 10 or 20 rupees, whatever you want. You can update to A. If the transaction happened concurrently, then the database will be consistent. Consistent, the term is correctness, means the updated database without any mistakes or flaws in it. Yes. So A wants to transact with B, and at the same time B wants to transact with A. So if these transactions happen concurrently, then your database is going to be an errorless one. So that is what your atomicity means. It will be happen if we want to do two transactions at the same time. It will happen at a single moment. Otherwise, it will not happen at all. That is what atomicity. It should be atomic in nature. Consistency. See, it is the rule, as I said earlier. See, whatever transactions you're doing, after doing all those things, your database should maintain some correctness. So that is what consistency is. So the third one is isolation. Okay, isolation in the sense, the same story I can have here. A again wants to transact with C relation. Just imagine A, B, C. They are relation or table, what we have discussed now, right? But here the thing is, no no interactions between B and C happens. Means the isolation will be happen and it won't disturb any other relation. Fine. So no interaction between B and C, and still the data remains consistent. Yes. Okay. The last one is durability. Okay. Have you? Okay. I'll come to the next. One commit, because we have one statement called commit. Let me ask the question later. Okay. Durability ensures that whatever the changes you have done, it will be saved in the database permanently. So that is what durability is. Okay. Next one, composite key. See here, I don't have any primary key, right? Okay, that is what we are actually impending. Okay, I'll come after this slide. See, I cannot uniquely identify any record from this. You can see here I have two Robert Phil, means maybe it is a name, and I did not mention any name here. You can just imagine that it is a name, it is an address, and this is what it is little, maybe the colony name or something like that. Okay, if you want to access the record of a certain person, how would you fetch the record? It is not possible by using a single field in the given relation. So I need two columns or attributes in this relation to retrieve a single record or more than one record. So that is what a composite key refers. I need one or more than one field. As someone has also said, yeah, field, you can represent it as field, attribute, column. Yes, it is possible. So that is what a composite key is. Okay, now let me come to primary key. Here I have mentioned customer ID as a primary key. Just think that I have included more than one Google or more than one Amazon and similar to Apple. What happens? I cannot fetch the record uniquely. Fine. So primary key is a key which uniquely identifies the tuple in a given table. So here I have three, ID. So it is unique. You can see that it is unique. Then don't ask me that this is not unique. Just for an instance, I have added this. But customer name, in the previous slide which I have shown, you could see that Robert Phil was twice in that particular relation, right? So you could imagine customer ID cannot be repeated. Fine. So once customer ID is allotted to the particular customer, the same ID won't be given to some other customer. So again, I repeat, otherwise I'll write here. Primary key uniquely determines the row or a record. What do you say? Okay, let me come here. SQL commands. This is the important one. Okay, then I have done my part, primary key, right? So then what about foreign key and even can have we are having more keys, right? Candidate key, foreign key. Anything can you say? Foreign key. Okay, no issues. I'll come that later, but I hope now everyone understood what is primary key, right? Okay, let us jump into this section, and I come to that later. Okay, SQL commands. So we know that we have these type of commands in SQL. Those who have already studied, DBMS, definitely you might have known this. First one is data definition language, data manipulation language, data control language, transaction control language, and data query language. Okay, here we can see that DDL comes, has these type of things like create, drop, alter, truncate. Okay, to create a table, we know that, right? So syntax for creating a table is, let me write here. Create table name followed by whatever field you want, if I want employee ID, I can give, let me give it as number and name. Used to do like that, right? And your worker simply you can give worker issues. So how much values you want, you can represent here, and so on. So this is the way you can create a table. So we know, everyone knows, I think those are connected. And next one is, so I just wanted to ask you one thing. What's the difference between drop and truncate? Drop and truncate. Can someone say what is? You can post it in a chat box. Very good, Pramod. Okay, drop means we can delete the entire table along with the definition. Yes, drop, what you have said is exactly correct. We can delete the table along with the definition, but truncate deletes the table alone, but the definition of the particular table still remains over there. And again, you have added one more question, like data and information. Obviously, usually this is usually the first thing which I should explain. Okay, data means what I said to you, like 50 students are there in a classroom and you're just adding all those in a Excel sheet or whatever it is data. But if you want to fetch a single record, the particular field or row, whatever we have discussed now, that row alone we are fetching, right? So that is what an information is. A database or a table contains a lot of information in it. But overall, we are saying it as data, but whatever you are fetching, that is what an information is. From table, yes. Okay, then alter, if you want to, you can use update command. And okay, alter is to, if you want to change the table, things, a few things like table name or something like that. We can do something over there, and DML, data manipulation language, insert, update, delete. If you want to insert records in a particular table, we are using insert statement. Update, if you want to set a salary to certain limits, if their performance rate is something like above 7 or something, we can set something, or 8, or the average is like that, we can set some salary range for that. So based on that, we can give the command. And last one is delete. If you want to delete the table, and we can delete it. And DCL, data control language, grant and revoke. Actually, this is for giving privileges. If you want to give access to someone to access to someone to access your database, then you can use this commands like grant, revoke. And if you want to revoke it, then we are using this revoke command. Means already whatever you have given, the permission you have given, if you want to withdraw it, you can give this command. And commit, if you want to save all those things, you can simply give commit command, and even the save does the same thing. And the rollback, if you want to undo, it is most probably it is related to undo the previous action which you have done. If you want to undo it, you can give this rollback. And obviously select, everyone knows already, I could see that one command like select statement is to fetch record. Okay, fine. Functional dependency, here it comes. Okay, I think so far I'm okay. If I get your yes or no, then I'll go in that flow. I hope everyone went to sleep. Is it so? Just post a message. Yeah, thank you, Mr. Ravi. Thank you so much. Okay, fine. So this is a functional dependency. See, if you know this, then normalization concept can be understandable. Today, what I have thought to cover is normalization. 1 enough, 2 enough, 3 enough, because I hope that few of the students are also available. I just don't want to make them confused, so I'll be just going going with these 3 enough to avoid confusion. Okay, here you can see relationship between attributes of a table dependent on each other. That's what I just want to clear with an example. Just imagine that we have a department relation or table, whatever you can you want, you can put over here. Department table with 2 attributes. One is department ID and another one is department name. As I said, I want to uniquely fetch a record, so I'm just giving here department ID. Okay, here department ID actually uniquely identifies the department name attribute. So what they mean is, I can fetch the record of I can fetch department name by getting the department ID. Sometimes, in most cases, department name, if I say finance, accounts, and computer science, the various streams are there, right? Even management. So I'll be assigning a single ID for each department. So most probably department ID won't be repeated for more than one department. It is unique, right? So it is vice versa. I can fetch the record of department ID based on the department name. So that is what they clearly indicates, that I could retrieve the record based on department ID. So there are 2 types of functional dependency. One is trivial and another one is non-trivial. Okay, so trivial functional dependency, I can fetch department. You can say it in another way, that department ID and department name belongs to the particular department table, and I can fetch the record, or I can say fetch the department name based on department ID. So it is common, right? In rare cases, if you feel that if you are assigning more than one ID like a management CA. If you are assigning more than one ID for the same department, there comes non-trivial functional dependency. See, I repeat, trivial functional dependency, it refers you are actually going to fetch the particular field based on the primary key. But non-trivial, what happens sometimes using the candidate key. I think here you may not aware of candidate key. I'll go to the previous table and I'll say you what candidate key is. Here I can assign this customer name as candidate key since it contains unique values. But I'm not going to set it as a primary key, but I can set here as candidate key. I cannot set the status as candidate key since it has more than one repeating value. So that is what a candidate key. It is most probably similar to primary key, but the best fit for this particular table is customer ID for primary key. That's why I'm not disturbing this one. But customer name, it is also unique in nature, so I'm terming it as candidate key. So this is what actually happens here. If you are trying to fetch the department ID based on department name, then it comes non-trivial functional dependency. Okay, so let us see an important concept called normalization. Okay. See, normalization usually whenever you might have heard that most of the interview questions will be asked in normalization, and it is defined as a single relation that results in data duplication. You'll be having enormous data, but mostly duplicated data exists in the particular table or relation. What happens? Normalization actually reduces the redundancy. It is much helpful in managing the large database. Apart from this, what I have mentioned, let us discuss. It makes relations very large, and obviously it is not easy to maintain and update data as it involves searching many records in relation. Yes, it is not possible to easily maintain and update data if your data is huge. And similarly, wastage and poor utilization of disk space and resources. Give me a minute. And similarly, wastage and poor utilization of disk space and resources. If you try to save enormous data in memory or something like that, definitely your space will be affected. Means you are not going to use that for some other purpose. So definitely it is not good, to handle duplication data. And similarly, errors and inconsistencies occurs obviously. So these are, if you are being asked like what is the purpose, what is the uses of normalization, definitely you can say these things. It will be going to be useful to you. And it is the process of organizing the data in the database. Yes, particularly it helps to organize the data, and it minimizes the redundancy. As I said, redundancy is duplication, and it divides larger table into smaller and links them using relationships. Just imagine, as we said that in the first point, if you have enormous data in a single relation, then it may contain 10,000, 20,000, or 30,000, records, and similarly more than 5 or 6 fields in a particular relation. Then it is somewhat tedious when compared to small size relations. So that is what this particular concept actually divides your larger table into smaller, and you can link them using relationship. And again, as we said, our database table, from the database table, redundancy can be removed. Okay, let us jump on first normal form. Okay, domain is atomic if its elements are considered to be indivisible units. Yes, here you can see they expect the domain to be atomic in nature, means the elements or values should be atomic. It should not be repeated. Repeated or more than one value for the entry is not allowed. like you can see student ID of 11 and 13. You can check this record. Phone number, it has dual entry, like maybe the values are different, but still more than one value is existing, means it is not atomic. This particular relation is not atomic in nature. You can say the 11 and 13. So what we can do, we are going, how I make it as 1NF. To make it 1NF, I'm just going to make the particular relation which contains all the elements in atomic. Here you can see that I have decomposed the student table like this. So what happens? I have, but anyway, you can ask me that 11, Joe and UP, it is still repeating. But what happens? I just, made the particular table atomic. Yes. So you, two entries for the single field is not allowed here. I made this particular given table in 1NF. I hope I'm clearing you. Okay, next one, 2NF. The first thing is it should follow 1NF. If the particular, if you're saying the given table is 2NF, then make sure it has already followed 1NF. And along with that, we have one more important thing, like all non-prime attributes are fully dependent on the primary key. Yes, here you can see the customer table available, and I have three columns or attributes named customer ID, store location. Here, I have 5 records, 1, 2, 3, 4, 5 as customer ID. And what they are saying, I'm saying that in this particular relation, 2NF is not, allotted, or it is not followed. So how I can change it into, first let me say why it is not followed. Because all non-prime attributes are fully dependent on the primary key. Here, what is non-prime attribute? We know that customer ID is a primary prime attribute, so we can leave it. Okay, again, store ID, right? Store ID is also, again, we can say it as a candidate key. And here, as I said, if you want to retrieve the store location, first we need store ID. Yes, because store ID can be assigned to one or more than more than one customer ID. So store location is completely dependent on store ID. So to fetch that record, what I should do, it is actually dependent. Non-prime attribute store location is dependent, right? So to make it clear, I have just split the customer table into 2 parts. So now there is no dependency for store location and customer ID. Yes, I repeat. See here, all non-prime attributes are fully dependent on the primary key. Yes, so here I have more than one, we can say it as a composite primary key, and this one is non-prime attribute. So I just want to make dependent on the customer ID, but it is not possible because store location is depending on store ID. It is not depending on customer ID. But what the thing is, the non-prime attributes are fully dependent on the primary key. They are asking asking the store location to be dependent on customer ID, but it is not possible because we can retrieve the record based on store ID. Fine. So for that, I'm just going to decompose the table into 2. Here I can say it as customer. Here we can name it as store. So what happens now? Store location in this particular table. Which one is the primary key? Can someone say? Let me understand. How many of you have understood primary key? If you are a basic learner of DBMS. Someone asked question, but I don't know which question you have asked. Student ID. I think I have gone there. Okay, I'll come back to you later. Non-prime attribute, Shubra person. That is what I said. See here, I can say it as a primary key, and these 2 can be termed as composite primary key, or even you can say it contains unique value. So we can say like candidate key. If this table, if the values are extending and if you're making some other alternatives or repeated values, then it cannot be termed as candidate key. But for an instance, I'm saying This one is a this and this customer ID and store ID can be termed as composite primary key. You can see here composite primary key. I hope you have remembered the previous one. Like if you want to fetch the record based on one or more than one column in a given record relation, that is what a composite key is. Here, store location is termed to be a non-prime attribute. Why? Because it cannot be a primary key, it cannot be a candidate key, because store location may be repeated in nature. So I'm terming it as non-prime attribute. These are prime because it contains unique values, but store location we cannot say that it contains unique value. Since if you are adding few more records, that obviously the store location may be same. So I cannot term it as primary key or a composite primary key. So I'm terming it as non-prime attribute. So this non-prime attribute is dependent. It should be dependent on, fully dependent on primary key. So that particular concept can be implemented by decomposing the given relation into two. That is what I have done. One is customer relation, where I have given two attributes like customer ID and store ID. So here I don't have any restrictions like because since it is composite keys, so I don't need to worry about it. But here you're saying that store location is a non-prime attribute, so it is depending on primary key. In this particular table, store ID is a primary key, right? So store location is dependent on store ID. So obviously our 2NF followed here. And similarly, I don't have any 1NF problem also here since it contains atomic value. So I have covered 1NF and 2NF. Okay. In the 3NF, relational must be in 2NF. So this is the first condition, what we have seen in 2NF. A similar thing also happens here. Transitive functional dependency of non-prime attribute on any super key should be removed. Okay. See, here they have given a single or group of multiple keys that can uniquely identify tuples in a table, almost like our composite key. If you are having two or more attributes or to retrieve a single record or more than more records, then it is termed as super key. Here I have an example to demonstrate 3NF. Here I have an employee table. As per the thing, what they are saying is, okay, let me explain first what is transitive functional dependency. Transitive functional, excuse me if I do time typing mistake. Okay, so if I say A tends to B and B tends to C, then it reflects A tends to C. Okay, so what they say is, if A is functionally dependent on B, B is functionally dependent on C, then it clearly indicates that A is functionally dependent on C. This is what a transitive functional dependency is. But here it should not be available or it should not remain in the given table. If it is there, then 3NF is not followed, it means. Okay, can someone say that is 2NF followed here? Can you say what are the non-prime attributes here? Can you guess? This is also again a question, right? So what I have done is, so here super key I have mentioned here, employee ID. If you are saying employee ID, yes, that is, it can be a super key. Employee ID and employee name. Using these two, you are trying to fetch some record. That is a super key, these two. And employee ID, employee name, employee zip. If you try to combine these three and try to fetch some record, then obviously it is also going to be a super key, and so on. If you want to take these four or whatever it is, right? So this is what a super key is. But here, what happens? Let us see. Employee zip is there, right? So this employee zip is dependent by state and city. Means state and city. like if you don't mention anything, you can't get the state value and city value. So obviously state and city completely dependent on employee zip, and employee zip dependent on employee ID. Then obviously, as we said, A tends to B, B tends to C, and A tends to C. So transitive functional dependency exists here. Again, I repeat, state and city dependent on employee zip dependent on employee ID. Then what happened? Obviously, state and city transitively dependent on super key, employee ID. Here I'm considering employee ID as super key. So obviously 3NF is not followed in this particular given table clearly. So again, some decomposition happens here. Employee and employee zip. So employee table, I'm just categorizing into, I'm just giving only 3 columns or attributes termed employee ID, employee name, and employee zip. Whereas in the case of employee zip, I'm just giving employee zip, state, and city. Here, I don't have any transitive dependency because employee zip depends on employee ID. No issues. Here also 2NF also followed. You can see employee zip. If I consider it as a non-prime attribute, then it depends on primary key employee ID. Then 2NF followed. And here state and city. Yes, so city, if you can depend on employee zip, which is considered as a primary key in this table, then it is also possible. So here I made my table to follow 3NF. Okay, normalization. Any doubts so far, or shall I proceed? Yeah, very good. Shall I proceed? If you say, then I will proceed with the. I think we have reached the last topic. Thank you, sir. See, database management system. See, these are the tools which you may be familiar. MySQL, these are the traditional ways which is easy to handle your relational database management system, where you can see it is free and open source. You can download in your system, and you can obviously use this particular IDE or software. It is completely free, and as we have seen this one, which you have learned, like select statements using some SQL queries. You can retrieve the record, or you can do certain things in MySQL. And Microsoft SQL Server, it is also a commercial DBMS, which it is not, we can say it is like a licensed one, and it can be divided into mainstream, specialized, and discontinued editions. In Oracle DBMS, obviously everyone might be familiar with that, and it is for OLTP and data warehousing. I think few of you have used also. Okay, let us see what is PostgreSQL. Many tools are available, but I have just taken only 5 into account, which are in the train and which they are actually using. Even I did not include NoSQL. You can also refer it, because these are the things which industry is preferring, because our structured database, everywhere we cannot assure that structured database exists. We can see that they are dealing with videos, chats, everything. The present data, it is not that much easy to work with the structure, RDBMS like thing. So we need some packages, libraries. Even you might have here SQLite. See, there are many packages available for programming languages also. And what the thing is, you have to go and learn. And many platforms are also available. They are open source also. See, PostgreSQL is open source and free one. You can even download. You can check in this link which I have given here. And once you have download, you could see that same picture will be displayed in your system. And this is the dashboard. And see, once you have installed, you could see under the servers, you can see PostgreSQL. That's the version, whatever you have installed, it will be displayed, and you could see these things. And you can create database, and under the database you can create a tables, And whatever you want, if you want to under the table, if you want to add some values, yes, obviously you can add it and you can work accordingly. Yes, so this is PostgreSQL. Now, I'm not touching it more since I don't install it. Since it's a guest lecture, I did not touch the component in advance. So just I'm giving you an introduction. Just it may be like a eye opener session. We have these tools available free for you, so you can download and make use of it. Yes. And next one is MongoDB. It is also a open source, NoSQL, document oriented, means you don't need to go with the traditional way to create your table, or if you want to select certain records, it is not required to do it in a traditional way. It is actually document oriented DBMS. So how the document looks like, as it is like almost similar to JSON. Okay, and even MongoDB Atlas, you might have here. It is an integrated suite of cloud database services. So here you could see that multiple databases can be connected easily, where you cannot say that it should be structured. No, it is not like that. You can integrate any type of data, and it is easily adaptable. Like if you're going with different uh, different values, and it is easily adaptable, and it can be easily integrated with your programming language, and it is good. Okay, high volume data storage is also possible here. So these things, these facilities are even being provided by MongoDB, and just imagine the two for open source. Yes, so definitely you can try this. And once you have installed successfully, if you want to create a database, just here I have given test as my database. So you can also give your own database name to create a new one. So what happens, it will create a new database for me, and it will switch to that environment. So once I have done, if you want to display, once you have given the statement, I just want to check whether my statement executed properly, you can give this show DBS. There you could find the several database, along with it the recently given one also should be included. And what is this? You can see db.users.insert1 means in my test database, insert1 refers I'm going to add a new user, only one new user. Here I have mentioned name as Max and age as 29. Here the fields are getting included or inserted under the test database. And similarly, we have insert many. If you want to add more than one, then you have to give insert many, then followed by commas. You can give it in double quotes, and you can give comma in between, just to separate those values. This is a field, this is the value. Name is the field, Max is a value, and again, age is a field, 29 is a value. So this is the process of MongoDB. Give me a minute. So you can see the manual also. Official site is also available. You can download your MongoDB from the system for your Windows or Linux or whatever OS you are having. And followed by C. This is the document. As I said, it is a document-based database. Here it is similar to JSON object, as we discussed earlier. Here, how we are actually going to give the values, field and value. In relational database, we are usually proceed with tables, right? But here we are going to give like field and values. It is mostly like a map concept. Key and pad usually we used to have, right? Here in the same way we are having field and value. Here name is a field, SU is a value, and age, status and groups are fields, and 26A new sports are values. See, it is much comfortable than our traditional one, because if you go, if you have given a single mistake, then it will not clearly indicate to us also. We have to search for a long time to come back with that error. But using this type of IDE or tools will help you quickly navigate to the next part. So you can refer all those things. You can see databases and collections are there, and the installation procedures also given here. So kindly go through this to make understand what MongoDB is. And you can ask me that how I can choose my, means which should I choose, like PostgreSQL or MongoDB. See, depends on the project you are working on. You can prefer, if means if you're going to completely working on your structured database, then you can go with the proceed with the traditional database. But here it is not required, like you should be addicted to a single one. Since you are a beginner to DBMS, I request everyone to learn many tools by downloading it, especially open source tools. You can download and you can practice it. See, as I said, MongoDB contains easy commands like use, show, and these are usually it follows by db.users, right? Also, whatever commands you want to give, you can give inside it. Okay, if you have any questions, then I can answer one or two and we can close the session. Yes. Can post question in chat box so I can read and explain.
The recording has stopped.
If you have any questions, you please type in the chat box or raise your hand so that I can unmute you. Feedback link is posted in the chat box of YouTube and Zoom. You can fill it.
Okay, someone has asked rather than reducing the redundancy of the data. Yes, Pramod. So that is what we discussed. No, we can make the relations like a split. If you are trying to split the relation into several relation, obviously your storage is going to be saved over there. So wastage of the space will be surely avoided, and errors, inconsistencies, obviously it will become reduced. Rather than reducing the redundancy, your error is also going to be reduced. And most probably the maintenance, it comes very easier when it comes to normalization. Yes, if you're having a table, large table, then it is not possible to maintain, right? So obviously these are the other advantages you can mention in normalization. That is what, Mr. Ravi. If you're going with your traditional RDBMS like things, then we can. If you're following only structured database formats, then it is okay. But if you want to extract images, videos, or those things, then we have to go with some advanced technologies. Like maybe they are new to you, or someone may be aware of it, like data science, deep learning, and machine learning. Those concepts will be highly efficient for you to do it. We can extract audio, video, images, everything, but depends. But what we covered today is completely for structured database, and only exception like PostgreSQL and MongoDB, it helps to fetch or include some unstructured data also. Yeah, thank you.
Thank you so much, madam, for your wonderful session. There are no more questions, madam.
Yeah, thank you, sir.
Thank you, madam. Participants, those who have filled the feedback form can leave now. Certificates will be sent tomorrow to your email ID. Feedback form is posted in the chat box. You can fill it, and after filling, you can leave.
Sir, can I leave for the session?
Yes, ma'am. Thank you,
Yes, sir.
ma'am.
Thank you. Thank you so much, sir.
Thank you.